I'm Sharon Blair. I come from Vancouver, Canada. I've been here for about 3 years, and I am the director of Catalysis. So we work in fuel cells, but I don't want you to feel like you need to know about technology to understand what I'm going to talk about. Fuel cells contain platinum. They produce electricity. They are an energy conversion device. So Catalysis, it's one of 3 centers of competence in South Africa. Fully funded by the Department of Science and Technology. It's a flagship program of the DST. They've invested over 500 million rand in fuel cell development to date. And over the 3 centers of competence, there's 5 institutions. We are co-hosted by the University of Cape Town in the Chemical Engineering Building, the Center for Catalysis Research, and Mintech in Randburg. What Catalysis is responsible for is development of platinum-based materials and components in fuel cells, up to a fuel cell stack. It's unfortunate we have this nice big block in front of here. You can see the catalyst. You're going to start to see everything you see is moving up the value chain. Each is a step moving up the value chain. We operate up to that point, the fuel cell stack. What we develop are platinum catalysts. So we convert the raw metal into a catalyst. It's just a platinum on carbon. It's a simple powder, and it's something that we have already developed products that are on par with what your Johnson Matthey fuel cells can produce. And we are ready to sell those products, and we are just starting to sell those products. We move one step up the value chain to right there, which is the membrane electrode assembly. All we do is we paint that platinum catalyst onto a membrane, and with a few other components, we assemble a new product, and that increases the value considerably. So if you think about the amount of platinum in a 3 kilowatt unit, there might be 2,000 rand worth of platinum. Typically what we do is we ship that out of the country. The catalyst is about 4,000 rand, so you double the value and have a bit of a margin. You move up to the membrane electrode assembly, and now you're talking 25,000 rand. So you can see that as you move up the value chain, the value that you're producing and the jobs that you're producing in the country are really quite valuable. We stop at the stack, and I think it's a very smart thing for the country to be looking at the early part of the value chain. I'll tell you a bit more about that in a moment. There's 2 things we want to do. We want to develop products that are on par with global technologies, and we're not trying to develop the South African fuel cell sector. We're not trying to develop the hydrogen economy for South Africa. I don't envision that you're going to be driving a fuel cell car anytime soon, and I actually hope we don't, because I think it would be a waste of our money. What we are trying to do is develop a global export economy. What we're trying to do is manufacture components in the country and ship them out. And if there is a benefit to South Africa, it is a very big advantage. I think you're probably aware that the manufacturing sector in South Africa has been hurting for a number of years. And one thing that the Department of Trade and Industry have done is they've created a means to beneficiate platinum group metals through the manufacture of catalytic converters. And I think it was a brilliant idea. I think it was an excellent means of creating manufacturing jobs in the country. For the catalytic converter manufacturing sector, 5,000 jobs were created, direct jobs, 25,000 indirect jobs. I think it was a tremendous boon for the South African economy. The problem is that they did this through incentives, and I think incentives are important to create the opportunities to manufacture so that the automotive industry would purchase. But they incentivize the manufacture of the catalytic converter. when you incentivize that, when you give tax breaks to the automotive companies to buy their catalytic converters from South Africa, it turned out very well. We created an industry that was shipping on the order of 20 billion rand at one point. And the problem was, in 2013, the DTI started saying, you know what, we've been putting money into this. We've been pumping money into this year after year after year. And now we're going to change the incentives to incentivize assembly of your automotive vehicle. And while that's also good for the manufacturing sector, it is something that has destroyed the manufacturing of the catalytic converter in the country. We have decreased by almost half or more the manufacturing of catalytic converters in South Africa, and it's not going to go up. I'd like to say it is, but it isn't. And the key to that is that the knowledge is not based in the country. Catalytic converters are 30-year-old technology, so as soon as the incentives go away, so goes the manufacturing. And what we are trying to do in South Africa is to develop the intellectual property in the country based on platinum components, so that we can control where the materials and components are made, and we can build a sustainable industry that can grow and flourish in the country. If you look at the platinum value chain for fuel cells, that was the images I have scrolling. Right now, we ship out the platinum metal. What we would like to do is manufacture the catalyst, which was that powder that I just showed you. Very simple. Painting it on a membrane, that's next. Fuel cell components, that's when it starts to require some advanced manufacturing. And in order to promote the manufacture of these components, we need to seek out the ability to find the skills in the country and companies that want to manufacture. This is gold plating, diffusion bonding, chemical etching, advanced techniques that we need in fuel cells, but can be used for other sectors such as heat exchangers or things that can be used in other applications, aerospace applications. So we develop materials, we develop components, but those components require advanced technologies that are available across the world that can be applied to new sectors. So these companies on this supply chain, they can make these components. Some of them can make them today, some of them with the right equipment can make them within 1 to 3 years. And so what we're trying to do is nurture the environment to create opportunities for small companies in South Africa to manufacture components that serve us to make our advanced technologies, but we also try and make sure that what they could deliver can be used for other applications, and so that they can bond metals that we can work with sheet stainless that's 50 microns thick. These are thin materials, but these are things that our companies can make in this country. They have the capability already. So if we can start to create the demand, that's something that can really help us out. I think it's really critical that we look at the early part of the value chain so that we get the opportunities and we get the margins and the control over components that are sold from the country at the early part of the value chain. The reason for that is because I think we can play on both sides. High-Sec Catalysis has leapfrogged by hiring people like myself. I was co-founder of a fuel cell company in Vancouver, and so that was the reason that they were attracted to having me here, because I understood the technology, but I also understood the business of taking something from the bench through to a product and what the steps are required. What we also hired is someone from Nissan who spent time in the automotive sector. We hired someone who is my former director, who I replaced, who had manufactured fuel cell catalysts from a very large company in the United States before coming to South Africa. So basically what we're doing is we have a leapfrog strategy. We leapfrog with people, and we leapfrog with technology, and we know what technologies need to be advanced, and we work on those. At High-Catalysis at UCT, we work on both conventional technologies, technologies that can be sold today, and technologies that can be sold in 10 years' time. So that's how we leapfrog, by hiring people who know what they're doing, by hiring people who've been in the space before and have the network, and can drive the innovations for the future. The other way that we can leapfrog is by working with foreign companies that have fuel cell technologies that are almost ready to get on the ground. And we work with them by agreeing to deploy their fuel cells on a telecom tower, for example. But if you want to put your fuel cell on a telecom tower, we'll do that with you and we'll partner with you, but you must accept South African technologies into your future products. So we want them to take our catalyst and our MEA into their products, and they've agreed to this. And so what we get is we work all the way to the customer, all the way to Vodacom, and we understand what the needs of the product are, and we actually develop our customer relationship along the way. But looking back to the fuel cell supply chain, as you move up, it gets more and more and more expensive. But as it gets more expensive, there are more jobs. And so many people in the country will say, why don't we just buy the fuel cells and put them on the ground and we'll create all these jobs? But the problem with that is that you incentivize that and it will not be sustainable in the same way that the catalytic converter sector is not sustainable. So if you purchase the units, put them on the ground, and you create jobs, as soon as you no longer have incentives, you can no longer afford to purchase those units. You can no longer afford to assemble fuel cells in the country anymore. And then all these people are stagnating and they don't have jobs anymore. What we are trying to do is create sustainability, and that is key to what we think is going to be the success. If there are to be incentives, tax breaks for manufacturing platinum-based components in the country, they should be temporary. They shouldn't last for very long. They should be only used to get a company off the ground. So to incentivize making platinum-based catalyst, membrane electrode assemblies and stacks, you can even incentivize the foreign fuel cell companies to assemble their units and to deploy them in the field and to provide much needed energy, as we all know is a crisis in this country. But if you do that, you're creating demand for South African components, South African manufacturing. And what it's doing, what in the process is driving our cost of production down so that we can compete with the world. And we've done the calculations, and we know we can compete. We can compete in the early part. And then we're not paying exorbitant prices for purchasing units anymore for foreign technology. We will have the ability to manufacture I don't want to get too much into the technology, but the very many components that the foreign fuel cell companies need, and to assemble the stacks and to put the units on the ground. We already have the people in the country that know how to take fuel cell units, put them onto a telecom tower, or it can be on a rural school, a mobile clinic, a rural hospital. If we incentivize that and drive the demand for it, then we have a chance at driving down our costs of production and becoming competitive on a global scale. We have recently hired a gentleman, also from Canada, who was responsible for MEA, that membrane electrode assembly, the catalyst painted on both sides of the membrane. He manufactured that for 15 years at what is the most famous fuel cell company in the world, which is Ballard. And he knows our costs. He knows the difference that we have and the advantage we have that a lot of people don't necessarily appreciate is that we make our own catalyst. We already do. It's already on par with the best catalyst that's out there today. So we're not paying for the price of the catalyst, we're paying for the cost of the catalyst. And with programs with companies like Impala, for example, they're loaning us kilos of platinum, and we can scale up our process, bring our costs down, and we can meet our customers' needs, and we can produce enough catalyst to meet customers' needs. So these are the little approaches that we are taking to driving the manufacturing of multiple components. And we're not doing it as high-stick catalysis. We're doing it with our partners in South Africa. So it really is a network in the country. It's a network of government organizations. It's a network of industry associations. It's a network of small companies, research institutions, and all under your nose. You probably weren't aware of all of the activities that we've been engaged in. We're working with the likes of Anglo Platinum, Lonmin, Impala. We're working with Vodacom and some big, large corporations in the country. And we're also working with tiny companies that are 1- and 2-man organizations that are trying to make a difference in their specific field. So if we can create, if the government departments, which we are talking to, things like the Department of Energy, state-owned corporations like Eskom, and other organizations that can drive demand, let's not compete for fuel cell technology in South Africa against commercial applications. Let's try and look at some of the rural off-grid applications. We can build our fuel cell stacks. We can provide energy to the local communities that are off the grid right now, and we can increase the demand for our fuel cells. It will cost a bit of money at the beginning, but it will alleviate an energy need, and it will also create demand for our products. And once we have demand for our products and can show we can make it in the thousands, this year we're looking at 5,000 to 10,000 per year. We already know how we can get to the 50 to 100,000 units per year. And so if we can drive the demand for this, we could demonstrate what we already know we can achieve in the future. We work with many different sectors, and we are trying to gain opportunities for so many organizations in the country so that they can benefit and we all can benefit from starting to see some of the manufacturing jobs.